All right, hello again, aficionados. So hopefully this is going to go a little more smoothly than the video I just did about, what to do if you can't find your beam. Um, this has been kind of pending for a while. I wanted to do a video about comma-free axis alignment. Okay. I did cover this previously in the video that I did about high-res imaging on the TechNI. But I can do, a much better job of specifically covering this specific topic now that we have, screen grabs with, and we can, we have the flu screen here as opposed to just, taking video of a computer screen. Um, so we're going to do that today. Okay. So let's start by, first of all, let me move the sample out of the way. Okay. So I want to start by first talking about what do I mean by comma-free axis. Okay, so the idea, right, is your objective lens. Um, if you have your beam traveling down the comma-free axis, then a point object will get imaged as a point. Okay, which is what you want, right? You want a point to be imaged as a point. Now, obviously, it's not completely imaged as a point because you have diffraction, right? So, even if we had a perfect lens, we would end up seeing an airy disk, right, rather than a point. But you also have other wonderful things like spherical aberration, and you also have astigmatism. And obviously, we can correct these to a degree now, right? On this system, we don't have CS correction as far as the imaging system is concerned. We have it for the probe forming system. But anyways, um, so even taking that into account, right? Even if we we remove the effect of astigmatism, we still have spherical aberration, so we end up seeing an enlarged point, but still a point. Okay, so if we're not along the comma-free axis, what we end up seeing is a point that has a tail. Okay, and so this is where the name comes from. So if you have ever seen a comet, right, streaking through the sky, or more specifically, it's actually, out in space and we can, see it as we view it through our atmosphere, you will notice that it has a tail behind it, right, as it's traveling along. Okay. So this is where the name comes from. Okay. Is you're trying to remove the tail from the comet. Okay. I have heard this pronounced a couple different ways. So I sometimes hear people call this the coma-free axis, right? And that's like, like I'm in a coma in the hospital. Okay. I never understood that, right? Because the idea is you're removing the tail from the comet. Okay. So, to me, it would make sense that you call it the comma-free axis, right? Because, you don't call it a comet, you call it a comet. Okay. But, anyways, potato, potato, right? I hear this said the same way. Okay. So anyways, we're going to talk about how to actually find the comma-free axis today. Okay. Um, so you need on your sample, in order to do this, you need a region on your specimen that is either amorphous or partially amorphous. So what we have here is a silicon wafer that's got a couple really thin epi layers on it. It has a coating of evaporated amorphous carbon, ding, ding, ding. And it also has some electron beam assisted platinum from the lamella prep process. So either of these two regions will work well for this, okay? And so you notice right now we are in SA mode at not really a very high mag. So you can do comma-free axis alignment in principle at any magnification you want, but where this is really helpful to do this is at very high magnifications, okay? So, and where that really, really shines, in my opinion, is when you go from SA and then you go into MH mode, okay? So if you go into MH mode, this is where, in my opinion, you really have the utility and the environment where doing comma-free axis alignment is important. Okay. So another thing to point out, so in the kind of the standard way that we do alignment, we have these two beam tilt pivot points, right? So if we do these, okay, so we're adjusting the beam until it doesn't move. So this is what's called tilt purity, meaning the beam is being tilted and then it's not moving, okay? You can do the same thing for the Y, okay, right there. Okay, and then once we do this, we can do what's called rotation centering, okay? So the idea here is that the objective lens is being wobbled and we want to minimize the shifting up, down, left, right of our image, okay? So now the reason this is called rotation centering is that there's actually a slight rotation to the image as this is taking place. So when we move that rotation to the center, then we don't see the shifting anymore. Okay, so that's actually why this is called rotation center. Sometimes you can see this when the mag gets really, really low. At these higher mags, you're really not going to see that. You're just going to see a shifting. Okay, so but anyways, that's where it comes from. Okay, so the thing to keep in mind is that when we do comma-free axis alignment, we're really adjusting, or we are actually, we're adjusting the exact same parameter that we're adjusting when we do rotation center, which is tilt of the incident beam. Okay, so keep that in mind, that there's really no difference between doing rotation center and comma-free alignment in terms of the actual parameter that we're adjusting. The difference is how we do the adjustment. So in this case, we're looking at the image. What we're going to see when we do the comma-free alignment is we're actually going to be looking at the FFT. Okay. All right, so now that we got that out of the way, I'm going to move up here. And I'm going to switch us into crazy high MH mode. And there we're into MH mode. Okay, and I'm going to bump this up just a little bit more. And then if you can move the sample out of the way, that is ideal, okay? So now that we are in MH mode, we can do the comma-free alignment, okay? So it's basically now, if you look through your direct alignments, you have now comma-free pivot point X and comma-free pivot point Y, okay? So now if I click this, nothing's happening, okay? If I click this, nothing's happening. So this is the same pivot point, basically the same pivot point alignment that I was doing here, okay? The difference though is I haven't set an amplitude for the tilting of the beam. So that's why we're not seeing this. If I go here to this pivot point, you can see, oh, right, this is out of whack, okay? So anyways, what do we have to do? Well, what we have to do actually is go into diffraction mode, okay, to actually set this. So I'll show you what I mean here in a second. So I'm gonna find the sample here. Okay, see if I can't get a little bit better focus with the Z. So when you're in MH mode, of course, I mean, I'll go ahead and do that. I'm gonna push eccentric focus. Okay, and then I see a little bit of an under focus, so I'm going up with the stage Z. I do have piezo enhancement here, so, and I have this set for a multifunction Y right now. I can use that as well. So that looks pretty close. Okay. So anyways, I need to be over something crystalline now. Well, I don't technically have to, but it's helpful. Okay. And now I'm going to go into diffraction mode. All right. So we see now a diffraction pattern. Okay. And you see now in direct alignments, I have two options here. So I have one for diffraction alignment. So if I click this, this allows me to shift the pattern around, okay? That's actually basically the same thing as what the default setting is when I go into diffraction mode, okay? Although what this does, that actually recalls the center position. That's what I'm doing here. I'm recalling a center position. But if I click on comma-free amplitude, okay, now you can see my multifunction X knob. Watch what happens. As I turn this clockwise, I see the pattern separating, okay? And basically the direct spot is bouncing back and forth between these two extremes. Now, when you click this comma-free amplitude, what you might have happen is, here, actually, let me turn this off here. Okay, let me put this here. I believe what happens if you click this, yeah, so when you do this, it actually puts it to where you have stored the position for diffraction alignment. So what you really need to do, click diffraction alignment and bring this guy to the center, okay, to start with. And then you can do the comma free, okay? So then the beam won't shift, okay? So what's happening now is we are determining how much tilting of the beam back and forth about the incident direction we're getting, okay? So when the beam is being tilted, what that corresponds to, let me switch to natural, that corresponds to a shift in the diffraction pattern, okay? So right in the middle, this was 0 degrees tilt, and then plus this much, minus this much, plus this much, minus this much, okay? So what we're setting is how much tilt plus or minus do we have when we do the comma-free alignment, okay? So the general rule with this is you want to make this about the same size as the aperture, objective aperture you're going to use ultimately. Okay, so if I go to the apertures panel, I know I'm going to use the 40 on this system. This is not image corrected. So, okay, and then I'm going to click adjust here. We switch to HDR to center my aperture. Okay, so I want my amplitude set so my extremes are basically right about at the edge of the aperture that I'm going to use, okay? So in this case, I think this is about 13 millirad, so I'm going plus or minus 13 millirad, okay, when I'm doing this. All right, so I have this set properly. I can click none. And now this is important. I don't want to leave this in, so I'm going to take out my aperture. I'm going to put it back in once we actually, do the comma-free axis alignment, okay? So I'm going to turn diffraction off. Okay. And I'm going to now, I'm going to pull the sample out of the way so we can see the whole beam. And you don't have to worry about the fact that this isn't perfectly a circle because we're going to spread it out anyway. But now we want to find comma-free pivot point X. Okay, so we can see this is off. Okay, so we're going to adjust this until we don't get any movement. Okay, looks pretty good. We're going to do the same thing with the Y. And now if this gets away from center, you can use your beam shift trackball to move that back. Okay, but this is critical. You have to balance these two pivot points properly in order for this to work. Okay, so again, what we're doing here is we're establishing what's called tilt purity, meaning as the beam is tilted, it doesn't move. Okay, that's called tilt purity, right? So now that I've done that, I'm going to spread out my beam, and now I'm going to go back to my material that I'm going to use. So this, again, this is E-beam assisted platinum, and this will work perfectly for what we need to do. Okay, so from here, I'm going to pull up the acquisition window. Oh, what happened to it? All right, let me restart. Someone's emailing me about a fib problem. What do we got here? All right. Let me just email or text this person back really quick. All right, so we're going to go ahead and start. Okay, and we're going to pull the screen out of the way. All right, so there's our E-beam platinum, and here's our FFT. Okay, so now we want a fairly short exposure time here. Okay, so 200 milliseconds should work okay. Now the first thing we have to do is we have to make the rings in the FFT circular. Okay, so go to Stigmator, click Objective, and let's make our rings circle like that. Okay, turn off the Stigmator, and then we can go to coma-free alignment X. Okay, so now what's happening is the beam is tilting. If it's doing X, I believe it's going from left to right. But what you're seeing here, what we're interested in here is how does the FFT look? Okay, so you can see that between the two tilt extremes, my FFTs don't look quite the same. Okay, so what I have to do now, you can see what it's doing. It's doing rotation center X, right? The same command that multifunction X used with rotation center. Okay, and so I'm going to adjust this until my two FFTs look the same between the tilt extremes. Okay, so if you see right there, that looks pretty good. Okay, now if I keep going further, see, now it doesn't look the same anymore. Okay, again, you're trying to keep the appearance between the two tilts as close as possible. It's not going to be perfect, most likely. That looks pretty good right there. You can actually digitally zoom in here a little. Yeah, that looks a little worse. Yeah, a little worse there. All right, that looks pretty good to me. Okay, so we're going to come back here, click done, and do the same thing for the Y. Although actually now, if it looks astigmatic, we need to correct that again. Okay, so we can come back here. And we'll do the same thing, coma-free alignment Y. Okay, so that looks to be a little bit off again. And now again, I'm using my Y knob, but this is now doing rotation center for the Y direction or the Y tilt. Okay, so that appears to be making the difference worse. So I'll go the other way. Okay, we're getting closer. And that looks pretty close right there, okay? You're going back and forth between the two tilt extremes and we're not seeing any change in the FFT, okay? So I'm gonna go ahead and click done. Okay, I still look good here as far as, no astigmatism. I'm gonna go ahead and do one more iteration here. Just check this again to make sure, but yeah, that looks fine. Okay, I'll do the same thing for the Y again, just to make sure. Okay, and so we're good. All right, so now what we need to do, I'm gonna put the screen back in. Okay, so now what we need to do is we need to put in our objective aperture and center it. Okay, so I'm gonna go back to diffraction mode. Okay, go ahead and center my direct spot there. Go to objective and put in the aperture that I was planning to use. Okay, and then go ahead and center this. And now we're going to have to correct the astigmatism again because we put in an aperture, but that's fine. All right, let's check the beam position here. Okay, it looks reasonable. All right, we'll go back to acquisition. Pull the screen out of the way. Okay, and now we see that there's some astigmatism there because, again, we put the objective aperture in. So again, activate objective. I just click the stigmator button on my left hand panel, and that should default to objective when you're in TEM mode. And we can make the ring the diffuse ring. So again, right, there's a ring in there that's from the crystalline component, okay? I'm not concerned with that. You can see it's this diffuse ring in the middle here, this dark ring. That's what I'm worried about here. And there we go. That's perfect, okay? So now I'm gonna move onto my material. Right, so this is the amorphous carbon. Okay, and then here is my area of interest right here, okay? All right, so one thing I can do here, I can rotate this. I turned off this crop to power 2. If this is on, see, it cuts off a lot of the view area. That looks pretty close. This does have this true align feature. So you can see here, I can drag this along the row of lattice fringes here. And there we go. Okay. All right. So now I'm just tweaking the focus. Okay. And now this is where if you have in MH mode, definitely that doing frame integration, drift corrected frame integration really helps. Okay. So we have right here, I have this set. Let's put this at 200 milliseconds and we'll put this at 10 frames. Oh wait, no, not, sorry. 1 frame for frame combining, meaning 200 milliseconds is split over 1 frame, and then we'll do 10 frames total. Okay. All right, and then let's go ahead and acquire. Okay, and then while this is happening, this was a trick I saw, we can actually do this. So DCFI, optimize for periodic images, then it's gonna sum up my individual frames. And there we go. Okay, beautiful. Okay, so there's actually right here, you can see this dark spot, this dark layer here. This is actually silicon germanium. And then above it and below it, there's actually just pure silicon. Okay, so very interesting structure, right? Our FFT looks really good. Not seeing, right, no astigmatism there. Everything's circular. So, and our defocus value is very small, right? So we're not deviating from eccentric focus very much at all. Okay. Okay, so that is how to perform coma-free axis alignment. Now, in principle, this is going to get you the best quality high-res image possible. Okay, better than just doing normal rotation center. Okay, how much of a difference? I don't know if you'd really be able to tell. All of the factors being the same, like if you had a decent sample to begin with. But in principle, this is what you have to do to get the best possible performance, at least when you're doing conventional high-res imaging. Okay. All right. So that is the second video that I wanted to do today, and that is covering coma-free axis alignment, otherwise known as coma-free axis alignment to some of you. And I, of course, respect your choice of language there, okay? So I'm going to try and bang out another video here today, and hopefully I can do this. So thanks for staying tuned, and hope this was helpful for you. All right, let me go ahead and Stop the video then.